Okay, here's another centroid problem. This one's a lot. This is number 65 from the textbook. Um, so it's determining the location of the x and y of the centroid C of the shaded area. So I know when you're looking at this problem, it looks really difficult. You don't know what kind of components you can see, but what you can do is that, so really you can imagine that this is just one big square. And now it looks like it just has a cutout here of a triangle. It has a cutout over here as a quarter circle, a radius of 1.5 inches. So now, I don't know why I keep, there we go. So now, that's actually going to make our problem a lot easier. So this is component 1, this is component 2, this is component 3. So the trick is sometimes is kind of looking at the bigger picture of the problem, where like for this one, it's a big square that has a cutout, a triangle over here, that cut out of a quarter circle. So when I'm calculating the areas of 2 and 3, they're both going to be a negative area because they're being cut away from the piece. While the square, like, is going to have a positive area. This would be the same way you would calculate the area of the shaded in figure, so it's kind of the same sense as that. So when we're looking at it, so we're going to have like the x, y, this is going to be just in the center, right? So it's going to be 1.5 inches, right? And it's going to be 1.5 inches to the center. Now, this here, this triangle, is going to be same in there. It's going to be 1.5 inches there, 1.5 inches here. But its center, its center, it's going to be around here, right? Because it's going to be 1/3 from here. So that's going to be 0.5 inches, if I'm doing my math correctly. 1.5 divided by 3. Yeah, that's 0.5. And it's going to be 0.5 from the top. Just because it's the 1/3 of that and the 1/3 of that coming from the fat end of both sides, which is this side. So that means it's, so like this whole thing is really 3 inches, right? So that means that this is really 2.5 inches, and also over here is also 2.5 inches, right? And again, you have to measure it from your axis in order to get the correct x and y coordinates. Now, for this one, we actually have to use an equation. So when we're looking over here, we have it here, the quarter circle. And so my center is, as you can see here, is 4 times r over 3 pi. So, and they're both the same, right? So the nice thing is though, this is at this corner, and we're given the radius, which is 1.5, so we can find this relatively easy. So we know this is 4 times r over 3 pi, and then same thing up here, it's 4 times r over 3 pi. Am I doing this right? I'm going to make sure one more time before I really dive into this problem. Yeah, okay. So, and this value would equal, if we did the math, so it's 4 times 1.5 divided by 3 times pi, right? It gives us 0.6366 inches. So now, when we're looking at this, So we're going to do, we have component 1, which is my square that's filled in. We have component 2, which is my cutout of a triangle, and then my component 3, which is my cutout of the quarter circle. So like I was saying before, right, the area of this is going to be in the positive sense, so it's going to be, right, for this, it's obviously just going to be the 3 times 3, right, just base times height of the square, which gives us a 9, so we have a 9, and then for my second, it's base times height over 2, so it's 1.5 times 1.5 over 2, which gives us an area of negative 1.125. Remember, it's being subtracted, so we have to keep that negative there. And then for my quarter circle, look at this. Okay. I don't know why I looked at that, but so to calculate my quarter circle, I do pi r squared over 4, right? Pi r squared being the area of the total circle, since this is the quarter area of it, divided by 4. So that means 1.5 squared times pi, and then divide that by 4. This gives us a negative 1.767. So when we're looking at this, we're going to have 9 minus 1.125 minus 1.76, and so on. So, my bad. There we go. So my sum right here is 6.107, and so I can fill out the rest of this using what I found. So this is also 1.5, and this is 2.5 here. This is 2.5 here. This is what I found, which was 0.6366. The nice thing about this problem, though, is that these all have the same values. So what I'm going to do, I'm only going to solve for one, and so that means my x bar and y bar will be the same value. So I'm only going to go through the steps solving for x bar. So we're going to have 9 times 1.5, which gives us 13.5. Then we have 1.125 times 2.5, which gives us a negative 2.812. And then we're going to get another negative value. It's going to be a little bit smaller, 6366. So it's going to be negative 1.124. So we do 13.5 minus 2.812 minus 1.124, which gives us total value 9.564, and you would get the same values over here since this is being multiplied by the same value, so you would get the same 64. So as you should know, the x bar is equal to the sum of x bar times a over the sum of a, and y bar is equal to the sum of y bar times a times area over the sum of area. So in this case, these are equivalent, so I'm just going to write out the one for them. So it's going to be 9.564 divided by 6.107. 6.107. That's going to equate to 1.566. So that gives me my x bar equal to my y bar, which is equal to 1.566 inches. So, and that is my answer for this problem. That's all there is to it. So the real trick for this problem is noticing that this is a square that's being cut by a quarter circle and a triangle. I'll draw it out again. So you have the square base being cut by this quarter triangle, quarter circle, and this triangle over here in this corner. So, and that's it for this problem. Again, it's real easy to put it into this nice chart to get everything, and this gives you everything you need to solve this Centroid.